Hey guys, and welcome to the full course on Introduction to Geometric Dimensioning and Tolerancing, your ultimate guide to mastering this essential engineering language for precision and communication in design, manufacturing, and inspection. This is a certified course, so don't forget to fill out the form in the description below after completing the session to claim your certificate. Share your achievement proudly on LinkedIn to showcase your new skills to the world. At Skill-Lync, we are committed to providing industry-relevant courses designed by experts to empower engineers and advance their careers. Before we begin, make sure to subscribe to our channel for more insightful tutorials, updates on advanced engineering tools, and details about our courses. Hit the subscribe button below and join us in this exciting journey of learning. Here's what we will cover in this training video. In the first module, we will start with the basics by introducing you to geometric dimensioning and tolerancing, or GD&T. Learn how this international system of symbolic language revolutionized engineering drawings, ensuring precision and reducing miscommunication in design intent across teams. We will also explore its origins, including the pivotal contributions of Eli Whitney and the idea of interchangeable parts, and how GD&T evolved as a cornerstone of dimensional engineering. In the second module, we will see a simple demo to highlight the practical significance of GD&T. From identifying the challenges of traditional dimensioning methods to understanding how geometric tolerancing eliminates ambiguity, this module will demonstrate why GD&T is indispensable for manufacturing, inspection, and delivering high-quality products. In the final module, we will discuss career paths and job opportunities in the world of GD&T. You will gain insights into roles such as design engineer, dimensional engineer, and dimensional inspector, as well as supporting professions like drawing checker and draftsperson. Discover how GD&T expertise opens doors to exciting, evergreen roles in industries ranging from automotive to aerospace and beyond. Thank you so much for joining us today. We are thrilled to have you on this learning journey. Don't forget to subscribe to our channel for more updates and detailed tutorials. Complete this session, earn your certificate, and share your accomplishment with your network. Let's dive into Introduction to Geometric Dimensioning and Tolerancing and unlock your potential to shape the future of precision engineering.
Good morning, one and all. This is Raja. Today's topic on geometric dimension tolerancing. I'll be taking you through the consecutive slides. So to have a brief introduction about myself, I'm working for an international OEM for the past 10 years. And day in, day out, I'm involved with 3D tolerance stack-up analysis. So GD&T is the base for this field. So my field, I would term it as complete dimensional engineering, wherein this GD&T is the base pillar for dimensional engineering. Raja from one of the international automotive OEM, and I'm involved with dimensional engineering for the past 10 years. And dimensional engineering, one of the base pillars for dimensional engineering is geometric dimension tolerancing, and that is the topic we are going to see in today's webinar. So the objective of the webinar would be to have an overview about GD&T and why it is important. The contents we are going to see for achieving this objective starts with introduction. We'll try to see what is GD&T, how it all started, what is the evolution in the field, and what is the basic fundamentals that is involved in the GD&T. Following which, I will share a simple case study which will show you what is the importance of GD&T. And following it, we will have a final slide of what are the available career path and job opportunities you have a GD&T knowledge. To start with, what is GD&T? GD&T, as it stands for Geometric Dimensioning and Tolerancing. It is an international engineering language used particularly on engineering drawings. In other words, it's an international system of symbolic language, and it is an effective tool available to make engineering drawings a better means of communication, starting from design through manufacturing and inspection. To stress on the first point, communication is a very important tool for any engineer. He may be involved in any field, but communication is the most important tool for engineers so that he will convey what is the intent and he will get the work done out of the intent. There should be no miscommunication, and the job done at the end should also be clear as per the initial intent. One of the effective tool available to convey your design intent is an engineering drawing. And this engineering drawing could be made effective and could be made mistake proof by using geometric dimensioning tolerance. So similar to any other language, geometric dimension tolerancing has certain grammar and punctuation rules that must be learned and practiced. And as I have already said, this is just another language. It takes time for you to learn and to practice and to expertise yourself in geometric dimensioning tolerancing. You could see different people from different sectors of industries. Some might be at the beginner level, some might be at the expert level, some who are conversational. Conversational in the sense they're able to read, they're able to write, they're able to recommend you a few things. So there might be different personnel across different industry sectors with a different level of GD&T knowledge. And as I stressed clearly, it takes time, practice, and effort to thoroughly understand and to expertise GD&T. Now that we have seen what is GD&T, what is geometric dimension tolerancing, this is just a quick preview. You'll understand how it all started, why it is again important. We'll have this slide recapped in consecutive slides so that you will get the complete loop of what is GD&T and how is GD&T used. To start with, it all started with Mr. Eli Whitney, who is a well-known inventor of cotton gin. Cotton gin is a machine. If you could see in the left side picture shown, cotton gin is a machine which separates the seeds and the cotton by using manual operations. So Eli Whitney is the inventor of this machine, and he is a notable person with whom started the geometric dimensioning tolerance. He is the one who promoted the idea of interchangeable parts. If you see here, I have given an explode view of a gun. And he is the one who advocated and promoted the idea of interchangeable parts. When I say interchangeable parts, the idea is to build a machine gun. Given any number of parts, you would be able to assemble with a different mix and match ratio. For example, if I have the hand lever here, there will be 30 plus. For example, if I say there is 30 plus hand levers given, you would be able to take any one of the hand lever and assemble it so that it gives you a gun with other parts. So he is one of the main personalities who advocated for this idea of interchangeable parts. The necessity for him to advocate the idea of interchangeable parts starts with World War, as in any case of scientific evolution. So the world required a system wherein you can have multiple parts and still achieve the assembled final product. And he was the one who promoted this idea, showcased before US government, and then got an approval for it. He then started his industry. That's all different history, but this is where from which the GD&T rooted. The main idea behind this idea of interchangeable parts is to have a tolerance for all the dimensions of a part. For example, if you see the barrel of the gun, the length will have a dimension, right? And his idea was mostly rooted so that this length dimension will have a tolerance for it. And this tolerance is noted down during the initial design intent, and during the manufacturing, it is made sure that always the length of the barrel falls within the tolerance. And during inspection, it is verified, and all these process all together gives us the idea of interchangeable parts. So that is, again, when you have lots of 30 different gun barrels, 30 different hand plastic parts and the different parts, you will be able to take any part from any lot and you will be able to assemble those parts for getting a final product of the gun. So this is where the world started to understand, yes, each and every dimension has to have a tolerance so as to achieve interchangeability. Before this gentleman, the process, all the manufacturing process were like handover from the father to the son. There were no specific tolerance idea as such, but it was a craft. Manufacturing was a craft before that. But after this gentleman started promoting the idea of interchangeability, people started to understand the importance of dimensions and tolerances, and then started application of tolerances. A dimension has a tolerance. What it directly gives us is a plus minus or the limit dimensioning system. For example, you see in the screen, there are multiple dimensions shown on the screen, but I have highlighted few dimensions. The nominal size or the mid size of the given dimension might be 35, but still it has a tolerance, plus 0.25, minus 0.25. So this is what the idea of Mr. Eli Whitney. Each dimension to have a tolerance so that it is achievable and ends up in interchangeability. So this was the system he was advocating and he was promoting, and by which he was able to build first interchangeable machine gun assemblies. I have shown different examples here. This is one of the examples of limit dimensioning. This is one of the examples of limit dimensioning. These are all examples of limit dimensioning or plus or minus dimensioning, the way you call it. There are different names to this. They say plus or minus dimensioning, limit dimensioning, and coordinate dimensioning. When I say coordinate dimensioning, what I mean is you are not going to dimension the different features in the part. Instead, you are going to dimension the coordinates of different features. For example, there is a drill here. The counter bore drill is available here. We are going to dimension the center point of the drill from this coordinate. You can see clearly it is 20 plus or minus 0.25. So this is what is called coordinate dimensioning. This being the starting point, Stanley Parker, a quality inspector from Royal Torpedo Factory in Scotland, found that there is some limitation of coordinate dimensioning. One of the main limitation, if you see, when we start to use coordinate dimensioning, what we end up is a square tolerance zone. I'll explain you clearly. Take, for example, the feature shown here, the counter bore hole. Let us try to understand what is the tolerance available for the axis of the hole. So the dimension available in the vertical axis is 10 plus or minus 0.25, and the dimension along with the tolerance available in the horizontal axis is 10, again with the tolerance of plus or minus 0.25. If you plot this, all this tolerance in a graph sheet, what you will get is this being the axis of the counterboard hole that we are interested upon, and 10 being the nominal size on both directions. We will have 9.75 and 10.25 as the lower limit and upper limit available for the axis location. When you plot all these dimensions together, what you get is a square tolerance zone. And this is the observation of Mr. Stanley Parker. And he stated this is a limitation of coordinate dimensioning. And he was one of the first people to initiate use of geometric tolerancing. When I say geometric tolerancing, Mr. Parker, instead of dimensioning and tolerancing the coordinates, he started dimensioning and tolerancing the geometry of the part. In our case, it would be the cylindrical hole here. Instead of dimensioning the axis of the hole, what he started to dimension is the hole geometry. This is where the GD&T started. The geometric dimensioning started. The geometric dimensioning and tolerancing started. From there on, people understood there are different geometries in every part, and if we control the geometries in every part, we will be able to achieve the final intent effectively and in the best possible manner. As we see, there are so many geometries available in any part. We have been discussing about a cylindrical hole till now, but if you see the same part again, when I say geometry, the cylindrical geometry, the flat geometry, all those geometries are available in any part. If you want to manufacture any part, you have to come across different geometries of the part. And to achieve the design intent of all these geometry, there were numerous methods across the world. And there came a time when the engineering world started to standardize all those geometric dimension tolerance methods. Even now, there are many standards available across the world, across the different industries, but two primary standards that are used across the world are ASME and ISO. The ASME stands for American Society of Mechanical Engineers, and ISO stands for International Organization for Standardization. ASME started with military standard. As I said earlier, it all started with World War II, and it all started for military purposes, and that's where the standard initiated. And it has evolved through the time, starting from military standard 8 of 1950s through to ANSI standards, American National System Standards, and now American Society of Mechanical Engineers. And the recent standard being Y14.5 2018. And ASME stands for American Society of Mechanical Engineers. Y14.5 stands for the Technical Subcommittee Member. And 2018 is the year of approval of the standard. Prior to this, we had 2009 as a standard that all the industries across the world were using, but now all the industries are updating themselves for the new standard released. When we talk about the other standard, the International System of Organization standard, you don't have a single standard as such, but you have a document saying what are all the standards you should follow for different geometries. I have listed few standards available. One you could see, this is the introductory note wherein to list all the different available standards. And 2768 is the tolerance for linear and angular dimensions. 5458 is the tolerance of positional tolerancing. And there are different standards listed in this particular standard. And when you want to refer about a particular geometry and how to use it, how to define it in your engineering drawing, you have to particularly go to a selected specific standard and you have to understand how to use it. So this being said, I'll try to recap what we have discussed so far. We have understood where GD&T started. It all started with requirement for interchangeability. And it all ended up for using geometric tolerancing instead of coordinate tolerancing. And from there, the field evolved wherein the standard started. Now we will see what are the basic fundamentals available in GD&T. And as I said, this is a recap wherein GD&T is an international system of symbolic language, and it is primarily driven by two standards. As I clearly stated, it will take time, practice, and effort to thoroughly understand the system. Now we will see what are the basic fundamentals of GD&T. I have listed the basic fundamentals for GD&T here. I'll take you and I'll give you a brief about different geometries available and different terminologies available in geometric dimension tolerance. As we were discussing, the aim of GD&T is to dimension and tolerance the geometry of the futures. And when I say geometry, there are different geometries available that could be form, the profile of the part, the orientation of different futures, the location of different futures, what is the runout for available future. All those you can term it as geometry, and they are further divided into the given line items. For example, form tolerance is further classified into straightness, flatness, circularity, and cylindricity. And the respective symbol available for straightness, flatness are given in this column. You can refer here. So these are the 14 basic symbols and geometrical controls available in GD&T. With these symbols, we will communicate what is our design intent in any drawing. Apart from it, there are also other terminologies like future control frame, datums, degree of freedom, 3-to-1 principle, general symbols, modifying symbols, material condition, bonus tolerance, datum shift, rule 1 or the envelope principle. And there are so many basic terminologies available in GD&T for any user to understand and to equip accordingly in his drawing. The intent of GD&T and having a standard across the world is to make the communication process a standard one. For example, in today's world, the engineering departments are divided in different countries. For example, the OEM I work, the designer sits in a different part of the world, the quality inspector sits in a different part of the world, and the manufacturer of the design intent part sits in a different part of the world. And there is a huge chance for miscommunication. This miscommunication can be reduced or completely eradicated when there is a standard method for communicating the design intent through all the stakeholders. And this is where all these symbols, all these terminologies comes in help. And when one understands all these terminologies, how to use it, how not to use it, what is the meaning of all these terminologies, what is the actual interpretation of all these terminologies, only then you can start to read a drawing. So I have listed few fundamentals here, and there are additional topics too available in GD&T for one to start at beginner level and to become expert through due course of time. What are the basic fundamentals in GD&T? And I hope you would be able to appreciate why do we at all need GD&T and what are the basic terminologies, what are the symbols available in GD&T. Now we will try to see a simple demo wherein we will appreciate the facts that we have discussed till now further, so that we will see the importance of using a standardized language across all the engineering commodities. The drawing you see in the screen is a simple part of thickness 6.25 on the tolerance plus or minus 0.25, having two counterbore holes on either ends and a radius here. The distance between the counterbore hole is 35, and that too has a tolerance of plus or minus 0.25. The overall length of the part is 55, and there is a radius available here, and the thickness of the part is given at tolerance. In this drawing. So the manufacturer and the quality inspector can have their own decision on how to measure this futures and what is the correct future, what is the wrong future, and which in turn will give us the alpha error and beta error. Beta error, okay, the good parts getting rejected is acceptable to a certain limit, but bad parts getting accepted in all industries. This is a simple demo wherein you can see the importance of communicating the design intent clearly. This is a simple case wherein I have given only one dimension and we have talked about the same dimension getting inspected and where it may end up in different errors. Think about cases where you have to design a medical equipment, automotive safety part, the seat belts, the restraints, the airbags, the seats. Think about any safety part, and if this is going to be your design intent, if this is going to be the way you are going to detail your part, it might end up in any one of the error and it might cost a huge to the company, and not to mention the damage it is going to happen to the human lives. So we engineers have a great part communicating the design intent clearly to the manufacturing and to the inspector personnels. And finally, we have to make sure that our design intent is captured as required and delivered to the customer perfectly. This is one simple demo of why we need a GD&T standard at all. There are so many other instances how GD&T will help us. For example, the square tolerance that we were talking before. Square tolerance is an illogical way, that being the starting point of dimensioning tolerancing. From there on, we have ended up in cylindrical tolerancing, which is more logical and which will more help to our manufacturing and interchangeability. And like such, we have so many additional benefits out of GD&T. So now being talked about the conventional method of detailing any part, this is the same part detailed using geometric dimensioning and tolerancing principles and methods. I'll take you through the part. We have been discussing about the thickness of the part, wherein we have given a tolerance. We have also constrained the geometry of the thickness or the surface straightness and the flatness of the surface, and we are depicting this surface as one of the main datum, and then comes datum B, and then comes datum C. And then if you see here clearly, what we are trying to do is we are trying to dimension tolerance the geometry here, the axis of the whole. And again, this axis of the whole is specified with respect to 3 datums. And the datum priority starts with A, followed by B, and then with C. This is just one example of future control frame. This frame we called a future control frame, wherein we are trying to control the future. And any future control frame, you have to read from left to right. Try to read this particular future control frame, wherein we are trying to position the axis of the cylindrical hole within a cylindrical dimension of 0.7 mm at maximum material condition, and with respect to datum A, B, and C. So this being the primary datum, B is the secondary datum, and C is your tertiary datum. If you use such method, we can think about the same example that we were discussing in the last slide. I'll just touch upon the inspection point alone, where you can see in this future control frame, for inspecting this particular hole, we are saying the primary datum to be considered for this hole should be, in all cases, the datum A, that is this particular surface. What we are trying to say is you should always rest this future first in your inspection. So now we are clearing out the ambiguity in inspection. You should not use any other surface to rest the part for inspection purpose. You should always use your datum future A. After resting your datum future A, you have to use datum B as your secondary datum. By secondary datum, what we mean is you should always use this surface for constraining other available degrees of freedom, followed by datum C, which will constrain any other available degrees of freedom. So what we are trying to do here is to communicate what is the method that you should use for inspecting this part. So any quality inspection personnel down the line, if he understands the GD&T, if he knows the rules and principles that has to be used in reading and inspecting a GD&T dimensioned part, will adhere to the rules, and there are no chances of miscommunication. And with this method, you can end up in always confirming that your design intent is captured clearly, and the final product you get out of the manufacturing and inspection line is in line with your design intent, and it always meets your functional requirement, and it always has no chance of errors. We have till now talked about only one benefit of GD&T, the inspection part of it. There are so many benefits associated with it, but I appreciate if you could think this point, and if you could understand this point clearly, you can see the whole importance of GD&T. Again, stressing to it, this is a language for communicating your design intent through all the downstream activities, starting from design through manufacturing, inspection. And there are different personnels available across different industries. Some might be well versed in reading the drawing, some might be well versed in defining the drawing, and some might be well versed in recommending the dimension, what the future should be used, what geometric control should be used. There might be different personnel across different industries. But always bear in mind this particular skill of reading a drawing developed using GD&T that follows any of the standard ASME or ISO requires time, and also personnels in any engineering industry must have a basic understanding of GD&T, only because this is the worldwide system. And if you see, I have listed on all the personnel who should have a basic understanding of GD&T, from engineering, design, drafting, tool making, manufacturing, inspection personalities, the procurement and quality personnels, and the CNC personnel. All these persons should have a basic understanding of GD&T, so that you will understand what is the intent of the part, what is the designer's intent, and how to validate, how to manufacture. All those things you can only understand if you can read and comprehend the GD&T details given in any engineering drawing. Understanding, digesting, and expertising yourself in GD&T can give you many career paths and opportunities, starting from design engineer, wherein you will design a particular part, understanding the functional requirements, and communicating those functional requirements through your GD&T symbols in the drawing. And then comes the dimensional engineer in the chain, wherein he will use the GD&T information available in the drawing, and he will see that all the given dimension and all the tolerances given for a individual part ends up meeting the design, functional, and appearance requirements. That is the role of a dimensional engineer. Then comes the dimensional inspector, wherein in real case he will check the parts in line and confirms that the part meets the design engineering drawing. Apart from it, you also have other supporting roles like drawing checker, drafter, wherein a drawing checker role is to read the drawing completely, to understand all the different terminologies and symbols used, and to make sure the drawing is complete and the designed manufactured part will meet the functional requirement. A drafter again is responsible for drafting the given part and functional requirements and the design engineer's direction. So these career path and job opportunities you see is going to be an evergreen field forever. There is production until there is manufacturing, until there is design of new parts, new products. These fields are going to be evergreen field, and the demand for these fields are increasing year by year. I have not shown any figures here, but you yourself can go and check in Glassdoor and other websites wherein you can see the salary and the demand available for different GD&T personnel. Nevertheless, these are not the only professions who should be knowing about GD&T, but also there should be other persons across different engineering departments who should also have a basic understanding of GD&T so as to deliver the responsibility.